Irrigation Engineering, Unit 3, Diversion and Impounding Structures. Syllabus, Types of Impounding Structures, Gravity Dam, Forces on a Dam, Design of Gravity Dam, Earth Dam, Arch Dam, Diversion Aid Work, Weir and Barrages. Diversion Work. The purpose of diversion work is mainly to raise the water level and the river flow into canal to feed the aqueduct. Impounding structures. Impounding structures means a man-made hydraulic structure, whether a dam across a watercourse or other structure outside a watercourse used or to be used to retain or store waters or other materials. Types of impounding structures: dam, weir, lake, ponds. These are all the impounding structures. Dam. Important terms in dams. Crust. Crust means the top of a dam used for roadway or walkway over the dam. Next, parapet wall. Low protective walls on either side of the roadway or walkway on the crust. Hill. Portion of dam in contact with ground river bed at upstream side. So, portion of dam in contact with ground or river bed at downstream side. Spillway. It is the arrangement made near the top of dam for the passage of surplus excessive water from the reservoir. Abutment. The valley slopes on either side of the dam wall to which the left and right end of dam are fixed to. Gallery. Level or gently sloping tunnel like passage at traverses or longitudinal within the dam with drain on floor for seepage water. Sluice way. Opening in the dam near the base provided to clear the silt accumulation in the reservoir. Freeboard. The space between the highest level of water in the reservoir and top of the dam. Dead storage level. Level of permanent storage below which in the water will be withdrawn. Diversion tunnel. Tunnel constructed to divert or change the direction of water to bypass the dam construction site. The dam is built while the river flows through the diversion tunnel. Types of dam. Based on the functions, the dam classified into storage dam, diversion dam, detention dam, debris dam, coffer dam. Storage dam is constructed during the rainy season when there is a large flow in the river. Diversion dam is constructed for the purpose for pushing water into ditched canal or other conveyance system. Detention dam. Detention dams are constructed for flood control. Debris dam. Debris dam is constructed to retain debris such as sand, gravel, and driftwood flowing in the river with water. Coffer dam, it is enclosed, constructed around the construction site to exclude water so that the construction can done in dry. Based on the structure, design, and materials, the dams are classified: gravity dam, earthen dam, rockfill dam, arch dam, steel dam, timber dam, buttress dam. Buttress dam are classified as deck type, multiple arch type, and massive head type. Classification based on hydraulic design, non-overflow dam, and overflow dam. Based on the size are hydraulic head and gross storage, small dam, medium dam, large dam. Small dam, the hydraulic head is 7.5 meter to 12 meter and gross storage 0.5 to 10 mcm. Medium dam, hydraulic head 12 to 30 meter height and gross storage 10 to 60 mcm. Large dam, hydraulic head greater than 30 meter and gross storage greater than 60 mcm. Weir. Weir is a solid obstruction put across the river to raise its water level and divert water into canal. Vertical drop wall or crust well. Upstream, downstream cutoff at the ends of impervious floor. Launching apron for prevention of scour. Types of wear: gravity wear and non-gravity wear. Gravity wear uplift pressure due to the seepage of water below the floor is resisted by the weight of floor. Vertical drop wear, masonry or concrete slope wear, drop stone slope or rockfill wear, parabolic wear, gravity wear, vertical drop wear, sloping wear. Sloping wear is divided into two categories: masonry or concrete sloping wear, dry stone sloping wear, parabolic wear. Vertical drop wear. Vertical drop wear or crust wall, upstream and downstream cutoff at the end of impervious floor. Launching apron for covering prevention. Graded inverted at downstream floor aimed to relieve the uplift. This is the cross section of weir. This is the shutter. This is the weir wall. This is the downstream side floor level. This is the upstream side floor level. Here we provide concrete blocks to stability, balance to the strength of wall. Here the concrete blocks, inverted filter. Here we provide file, upstream side file. Here it is the downstream side file. Masonry or concrete slope pier, suitable for soft sandy foundation, generally used where the difference in weir, crust and downstream river is limited to 3 meter. Hydraulic jump ID is formed on sloping crust. This is the rubble apron level we used in for rectifying or controlling the abrasion. Next, dry stone slope pier, body wall or weir wall. Upstream and downstream rock fill laid of glaciers with few intervening tear walls. Parabolic weir, similar to spillway section of a dam. Body wall designed as low dam system to dissipate energy. Non-gravity wear. The floor thickness is kept less. Uplift pressure resisted by bending a reinforced concrete floor. Type of wear based on the shape: rectangular wear, triangular wear, trapezoidal wear, short crested wear, broad crested wear, narrow crested wear, ogee shaped wear. Rectangular wear is in standard shape of wear. The top of each wear may be short crested or narrow crested. Triangular wear. The shape of the wear is actually triangle and V-shaped. Trapezoidal wear. Cipolity wear, trapezoidal in shape and modification of rectangular. Because cipolity wear, the side slope is 1:4 ratio. Then it is considered as a rectangular flow. Short crusted weir. The crust of the weir is very sharp such that the water will spring clear of the crust. Broad crusted weir. These are constructed only in rectangular shape and suitable for the larger flows. Head loss is small in case of broad crusted weir. Narrow crusted weir. It is similar to rectangular weir with narrow shape crust at the top. This is the cross section of rectangular weir, and this one is the cross section of triangular weir. This is in triangular shape. This is the cross section of trapezoidal weir. This is the cross section of trapezoidal shape. This is the height. This is the length. Sharp crusted weir. This is the crust portion. Here it is called as the crust. So crust is sharp portion. Then the flow is very clearly. Then only we use the sharp crusted weir. This is the broad crusted weir. This is wall. This is the breadth. height. Breadth is less than height, then it is called as broad crested weir. Breadth is less greater than height, then it is called as narrow crested weir. Ogee shaped weir. The top, the shape is called as ogee shape. Then it is called as the ogee shaped weir. Ogee shape, the fall flow through the wall. Along with the wall, the falls flow. Then it is called as ogee shaped weir. Next, gravity dam. A gravity dam is a structure which is designed in such a way that its own weight resists the external forces. This type of structures is most durable and soil and requires very little maintenance. That is the typical cross section of dam. This portion is called as a drainage gallery. This is the vertical face, this landing face. This portion is called heel, and then the front portion of this portion is called as toe. Forces acting in gravity dam. Weight of the dam, the self weight of the dam, then water pressure, uplift pressure from the base, earth and silt pressure, ice pressure, wind pressure, thermal pressure, wave pressure, earthquake pressure. Axis of the dam. It is the line of upstream edge of the top of the dam. Length of the dam. It is the distance from one abutment to the other measured along the axis of the dam at level of the top of the dam. Structural height of the dam. It is the difference in elevation of the top of the dam and lowest point in the excavated foundation. Toe and heel. The toe of the dam is the downstream edge of the base and the heel is the upstream edge of the base. Maximum base width of the dam. It is the maximum horizontal distance between the heel and toe of the maximum section of the dam in the middle of the valley. Hydraulic height of the dam. It is equal to the difference in elevation of the highest controlled water surface on the upstream of the dam. Next, earth dam. A earth dam is made up of earth built up by compacting successive layers of the earth using the most impervious materials to form a core and placing more permeable substance on the upstream and downstream side. Types of the earthen dam: homogeneous embankment type, zone embankment type, diaphragm type. These are all the three types of. This is the homogeneous type embankment. This is the homogeneous embankment with provided drainage filter. Here is the seepage through the drainage. And this is the impervious foundation zoned type embankment. Here we provide the additional layer transmission filter medium permeability. This layer is in zoned type of embankment type. This is the diaphragm type embankment. This is the diaphragm embankment, diaphragm impervious foundation or bedrock. Design principles. The filling materials to be used for earth dam should be sufficiently less permeable. Sufficient outlets and spillway should be provided to avoid the possibility overtopping during design floods. For frost action, wave action, and earthquake motion, sufficient freeboard must be provided. Criteria for design of earth dam. Sufficient spillway capacity and freeboard are provided so that there is no danger of overtopping of the dam. Uplift pressure due to the seepage underneath is not enough to cause piping. The stresses imposed by the embankment upon the foundation are less than the strength of materials in the foundation with its suitable factor of safety. Causes of failure of earth-filled dam: hydraulic failure, seepage failure, structural failure. Hydraulic failure due to overtopping, frost action, formation of gillies. Seepage failure due to piping through foundation, and piping through dam body or sloping of downstream to structural failure due to sliding of foundation and sliding of embankment. Next, arch dam. An arch dam is a dam curved in plan and carries a major part of its water load horizontally to the abutment by arch action. The balance of water load is transferred to the foundation by cantilever action. Types of arch dams. Constant arch dam, variable radius dam, constant angle dam. Constant radius dam, arch dam is the one which the radius to some prominent feature is constant. Variable radius arch dam is the one in which the radii, the extrudos curve and introdos curves. Constant angle dam is a special type of variable radius arch dam in which the central angle to the horizontal arch rings is of the same magnitude at all directions. Advantages of arch dam. Arch dam are particularly adapted to the gorges where the length is small in proportion to the height. Because of much less base width, the problem of uplift pressure are minor. Forces in arch dams, water pressure, uplift pressure, earthquake pressure, silt pressure, and ice pressure. In next class, we see the design of arch dam. Thank you.